Hi everyone, I am Mrs. H. Fatima, Assistant Professor in Mathematics, Hindustan College of Engineering and Technology. In this video, we shall see how to solve Lagrange's linear equation. The equations of the form PP plus QQ equal to R, where PQR are functions of x, y, z, is known as Lagrange's linear equation. To solve this equation, we have to first form subsidiary or auxiliary equations dx by p equal to dy by q equal to dz by r. We can solve this in either of the methods, either by method of grouping or by method of multipliers. In this video, we are going to see how to solve Lagrange's linear equations using method of grouping. Now see the problem. Solve y square z by x into p plus zx into q equal to y square. The Lagrange's linear equation, to solve this equation, first we have to form subsidiary equation or auxiliary equation. Send it. Here p is y square z by x, q is zx and r is y square. So the auxiliary equations are dx by p equal to dy by q equal to dz by r, that is dx by y square z by x, that is equal to dy by zx, that is equal to dz by y square. Now the x in the denominator goes to the numerator in the first ratio. So consider in the first two fractions or ratios, we get x dx by y square z, that is equal to dy by zx. Now we have common term in the denominator z. Okay, common term z in the denominator. So cancelling z, we get x dx by y square is equal to dy by x. On cross multiplying, we get x square dx equal to y square dy. Now integrating, we get the solution. So integral x square dx is x cube by 3. On the right hand side, integral y square dy is y cube by 3 plus constant. So C1 is x cube minus y cube, on cancelling the common denominator. Now consider the next two ratios, that is the first and the third ratios. We get x dx by y square z is equal to dz by y square. On cancelling the common y square in the denominator, we get x dx equal to z dz. On integrating, we get integral x dx is x square by 2, right hand side, z dz, integral z dz is z square by 2 plus constant. So the other constant is x square minus z square. Now the general solution is f of c1 comma c2, that is the first and the second solutions, that is equal to 0. So f of x cube minus y cube comma x square minus z square is equal to 0 is the general solution. We shall see with another example. Solve p tan x plus q tan y equal to tan z. Now the subsidiary equations are, here p is tan x, q is tan y and r is tan z. So dx by p equal to dy by q is equal to dz by r is dx by tan x, that is equal to dy by tan y, that is equal to dz by tan z. Now taking the first two ratios, dx by tan x is equal to dy by tan y. Now 1 by tan x is cot x, so cot x into dx equal to cot y into dy. Now on integration, what do we get? Integrating the above, we get integral cot x dx is log of sin x. log sin x. Okay, so integral cot x dx is log sin x, that is equal to integral cot y dy is log sin y plus log constant. So see, in the right hand side, sin x equal to c1 into sin y. Okay, so sin y goes to the other side. So what is c1? Sin x by sin y. Similarly, we can consider the next two ratios. Sin y is equal to c2 into sin z, that is dy by tan y is equal to dz by tan z. So similar results we get. Okay, so c2 is sin y by sin z. Now the required general solution is phi of c1 comma c2, that is equal to 0, which is phi of sin x by sin y comma sin y by sin z is equal to 0, where phi is arbitrary. Hope we understood this Lagrange's linear equation. Thank you.